In the finding length of a line video, we looked at how we could find the length of a line segment given the endpoints as coordinates. In this video, we will use coordinates to find the midpoint of line segments. The midpoint of a line segment is given as m is equal to x1 plus x2 over 2 and y1 plus y2 over 2. As with finding the length of a line where we got an exact value, we won't get that exact value using the midpoint of a segment. We will actually get the midpoint. So we will get the coordinates of where the midpoint is located. So let's look at some examples. So the question, we have 2 points, point P and point Q. So graphically, it will look something like this. This white line is what we will be finding the midpoint of. So we can see that the line starts at -3 and ends at +7. So if we count up all these points here, we will get the length of the line, and we learned the formula from the last video, so we could find the length of the line. So if we count these points here, from ear to ear would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we divide 10 by 2, we would get 5. So when we count to 5, that's where our midpoint will be. So our midpoint would be at 2. So we are expecting our midpoint to be right there. Let's apply the midpoint formula to see if that's what we get. So the midpoint formula, m is equal to x1 plus x2 over 2 and y1 plus y2 over 2. From the coordinates given, we see that our x1 is equal to -3 and our x2 is equal to 7. Divide this by 2. Our y1 is equal to 5 and our y2 is also equal to 5. And we divide that by 2. So -3 plus 7 would be 4 over 2, and 5 plus 5 would be 10 over 2. 4 divided by 2 would be 2, and 10 divided by 2 would be 5. So this is our coordinate. If we look here where we said our point would be, we see that our x value is 2 as we have here, and our y value is 5 as we have here. So we see that we can look at this graphically to find the midpoint as well as to use the midpoint formula. I would advise that you use the midpoint formula because this is only applicable, or it is easier to do when our line is horizontal. For a case where our line is diagonal, we won't be able to look at this graphically and find the midpoint that easily. So let's look at an example where we have a diagonal line. So this is our question. Graphically, it would look something like this. So this is what it looks like. And this is the line that we will be finding the midpoint for. We can find our x coordinate, and we can draw a vertical line up to our graph to find, or up to our line segment rather, to find our midpoint. But we won't always know the exact value of that y. So hence the use of this formula. So m is equal to, as we said before, x1 plus x2, divide this by 2, and y1 plus y2, and divide that by 2. In this example, our x1 is equal to 3, and our x2 is equal to -9. We divide this by 2, y1 is 5, y2 is 10. Divide that by 2. 3 plus negative 9 would equal to negative 6, and we divide that by 2. 5 plus 10 is equal to 15, and we divide this by 2. Negative 6 divided by 2 is equal to negative 3, and 15 divided by 2 is equal to 7.5. So these are the coordinates of our midpoint. Graphically, this point is our 3 and our x-axis, so this is our x-coordinate. And if we go all the way up to our line segment, then this point should correspond to 7.5. This is not drawn to scale, but if it was, then where it meets here would be 7 point. So this is our question. Graphically, we will have something looking like this. So this is what it would look like. This closed figure is the triangle that is constructed by those 3 coordinates. And we are going to find the midpoint of this segment here, BC. So the midpoint should fall somewhere. This is an horizontal line, so it's quite easy to find. So our midpoint should lie somewhere at 4, 6. So let's test to see if that's the case. Well, we actually know it's the case, but let's prove that. So M, as we know, is x1 plus x2 over 2 and y1 plus y2 over 2. So remember, we're using the coordinates of B and C. So x1 would be equal to 1, x2 would be equal to 7, and we divide that by 2. y1 is equal to 6, and y2 is equal to 6. We divide that by 2. 1 plus 7 is equal to 8. We divide that by 2. 6 plus 6 is equal to 12. We divide that by 2. Our coordinates are 4 and 6, as we can see here that we showed graphically. Let's look at a next question. So this is our question, and as you can see, I already did the graphical representation. So we're going to find the center of the circle. By the way, this is not drawn to scale, so if the white line doesn't seem to cut through the center of the circle, it is meant to be through the center of the circle. The white line should represent the diameter of the circle. So let's get back to the question. We're going to find the midpoint of this line here. We're going to use the same formula. M, which is the midpoint, is equal to x1 plus x2 divided by 2 and y1 plus y2, and we divide that by 2. In this example, x1 is equal to 3 and x2 is equal to 3, and we divide that by 2. y1 is equal to 3 and y2 is equal to 9, and we divide that by 2. 3 plus 3 is equal to 6. We divide that by 2 and we get 3. 3 plus 9 is equal to 12. We divide that by 2 and we get 6. So these are the coordinates of our midpoint. So our midpoint would lie right here. And we could look at this graphically and tell, because if we count what's on the upper side of 6, we'd get the same value as what is beneath 6 to 3. So remember that the line starts at 3. So above we have 7, 8, and 9, and below we have 5, 4, and 3. So we can see graphically that 6 would be our y coordinate, while 3 would be our x. And this is how we use the formula to find the midpoint of a line segment. Thank you for watching. I think this is the end of this video. In the next video, I think I will be looking at finding gradients maybe, or something that have to do with coordinate geometry. So again, thank you for watching.